Um, Hi everyone. So this is the second worksheet that we go through on Monday, and it's about two-dimensional electric field addition, and it's all about vector addition, which I understand that because many of you haven't touched this vector things for 1 and 2 years, and yes, it's hard to bring those things back. Okay, so let's go through this worksheet together. Okay, the problem statement is that the goal of this worksheet is to practice adding up electric field vectors, i.e. E equals to E1. We have this kind of arrow on the top because to indicate that this quantity is a vector instead of scalar. Okay, without numbers, for each of the arrangements of charges shown, which arrow best represents the direction of the electric field at x? In some cases, the electric field may be 0. Okay, so let's do this. So for problem 1, we have negative charge on the left and a positive on the right. They have equal magnitude of electric charges. Okay, so at this position, E1 is pointing to from this point to the charge because it's negative charge. All right, so it's pointing this way, and E2 is generated by this positive charge, and it's pointing in this way from the positive charge to the position. Okay, it's in this direction. And again, recall the formula we talked about before. E equals to K times Q1 over R squared. Let's just write Q. Okay, R squared. So here we can see that R, which means the distance between the position and the charge, are both square root of d squared plus d squared, which is root 2d, right? And they have the same amount of charge, which is q, 1q. Therefore, their electric field has the same magnitude, which means the length of this red arrow and this blue arrow are equal. Then, to make a vector addition, then we can draw a graph to show this. Okay. Okay. So the sum of these two vectors is this black one, the black arrow in the middle. You can imagine that you move this red arrow horizontally to this position. So basically, we can move this red arrow to here. Okay, And then you can imagine that a person walk from the starting point to the end of the end of the first arrow, which is the blue arrow. So a person work from here to here, and then from here to here. Okay. A person work from here, this place to this place, and then to this place. So it's equivalent to another person walk from this position directly to this position. Okay. So yeah, this is kind of the idea of vector addition, which means that the sum of two vector is equivalent to another vector. So in here we can say that the sum of this blue vector and this red vector is equivalent to this black vector. Okay. So now let's move to this one. The Q1, the E1 generated by the positive charge is pointing in this direction. However, E2 generated by this negative charge now is in the same direction, but with a larger magnitude. Oh, by the way, in the first problem we should choose C, the arrow, the black arrow in the middle. Okay. And here, because it's no longer minus 1q, now it's minus 2q. If you see this formula, we have E equals to k times q over r squared. So if we change this q to 2q, then we double the length of this blue vector. Okay, and to add this two vector up, we draw some lines to help us to move, to add these two vectors. I should draw it a bit better. Okay. If you have rulers or some better drawing tools, I believe you guys can draw better graph. But okay. Okay. This should be horizontal. Horizontal. Okay. So basically, that we double up. We double up the length of this blue vector here. So previously, our blue arrow is this length. Is this long. Here we have this minus 2q, so the blue arrows double up. Therefore, the sum of this red and blue arrow, or the blue vector and the red vector, will be pointing to the left down. I think we can see this better here. Okay. Basically, this is the answer. This line is the answer of problem 2. So the difference is caused by this minus 2q. it double the length of this blue vector, so that makes the sum of this blue and the red vector pointing to the left down. Okay. And now let's look at this part 3. Okay. In this position, then E1 is caused by this blue by this charge 1. It's pointing in this direction. This is E1. Okay. And E2 is pointing in this direction. It should be smaller. Well, I think my drawing is sort of bad. So let's see whether the solution key can show this things better. Okay. You can see that. So let's label this as a blue arrow. So this E1 is caused by charge 1, and this E2 is caused by negative charge 2. Okay, and E3 is caused by charge 3 down here. And E4 is caused by this charge. Okay. So the problem is how to add this 4 vector into one vector. And let's see. So E equals to E1 plus E2 plus E3 plus E4 plus E4. Okay, and here it's same as the scalar addition. If we add A plus B plus C plus D, then it's equivalent to we can add up A and C together first, and then we add B and D. So for vector, it's the same. It's the same. We can add E4 and E2. We group them as one and made the addition first, and then we add up E3 and E1, and then we add the sum of E2 and E3 with the sum of E1 and E3. We add the sum of E2 and E4 with the sum of E1 and E3. Okay. So the sum of E1 and E3, we can tell that it's pointing up. It's pointing in the upright direction, because both E1 and E3 they both point up, right? So E2 and E4 here, we have to consider, do they have the same magnitude? Do they have a similar direction, or a symmetric direction? So E4 is caused by this charge. The distance between this charge and this place is the distance in between. Okay, and this is equal to the position from this point to charge 2. Okay, so this and this, they are equal, and this is negative 1q and this is positive 1q. Therefore, based on the formula, we know that their electric field has the same magnitude, and they are symmetric. They're symmetric. They're symmetric about the y-axis. Therefore, if we add this to vector, then the sum of this E2 and E4 will point up. So giving you a let's say have a Cartesian coordinates y and x. Okay, and we assume there are two vectors with the same length of 1. They have the same length. Okay, same length. Okay, they're both length of 1. Okay, then if this angle, let's call it alpha, and this angle, if angle alpha is equal to angle beta, then this vector, let's call it E1 and E2, if angle alpha is equal to the angle beta, then the sum of these two vector E1 plus E2 will lie on the y-axis, because if angle alpha is equal to the angle beta, then it means that they are symmetric about y-axis, and therefore the sum of these two vectors will lie on the y-axis. Okay. Therefore, the answer of problem 3 is pointing up. Okay. Now let's see problem 4. So it's the same procedure. E1 produced by this positive charge here, and it's this one. And E4 is also produced by a positive charge, so we use a red pen to label E4. Okay, and we use blue pen to label E2, which is generated by the negative charge located here. Okay, and E3 is generated by the negative electric charge E3 here. Okay, so the sum of E2 and E4 will point up, but the sum of E1 and E3 will point down. Okay, and the sum of E1 and E3 will have a let me draw another graph here. Okay, so now we have we have two vector. Okay, this vector pointing down is e1 plus e3. Is e1 plus e3. Okay, e1 plus e3 pointing down. And we have another vector which is e2 plus e4, because they are symmetric about this y-axis. e2 plus e4. However, e1 plus e3 is larger than e2 plus e4. Why? Let's see the magnitude of e2 and e1, e2, e3, and e4. Okay, so e1 is k times I should red pen. Okay, k times q1. q1 is plus q. Okay, and r1 is this distance, which is d over 2. d over 2 squared. And e3 is the same magnitude. It's just we just change this q to minus q. Okay, and e2 is different. We have k times q. Should be minus q, but let's get rid of the sign. And the distance between this and this point should be so the square root of 0.5 d squared plus d squared, which is root 5 over 2. You guys can actually do this by calculator if you're not very familiar with the numbers here. Okay, so it's root 5 over 2 d squared, and you can see that this number should be smaller than this number, right? Because the denominator is larger than the entire the number itself will be smaller. Okay, so this e2 has a smaller magnitude of e1 and e3, but e2 has the same magnitude of e4. Okay, and then if we add them up, we draw the line to the middle, and this gray one is e2 plus e4. Okay, this gray one is e2 plus e4, and we can see that and actually it's green. Okay, green. And e1 plus e3 will be this long. So that yeah, just want to show you that e1 plus e3 is larger than e2 plus e4. Okay, so here we should choose pointing down. We have this d. Okay, so now let's do this. Okay, 5. E1 is generated by charge 1 is pointing down, and E2 is pointing to this direction. Okay, it's pointing to this direction. And we need to figure out the magnitude of E1 and E2, because otherwise we cannot know whether we cannot know where the summation of these two vectors. If you try to imagine that if we enlarge this vector, blue vector, to this line, then the sum of these two vectors will be, again, move the right arrow from here to here and connect this. Okay. If the blue arrow is this long, then the summation of blue and red vector will be this one. However, if the blue vector is only this long, then the summation of these two vectors will be this. Okay. So the summation of vectors is not only about the angles, but also the magnitude of that vector. Okay. So here, actually, we have the same magnitude, which means E1 and E2 they are equal. They're equal to each other. That's wrong. Let's go through the calculations fast. So E1 equals to K times Q over D squared. Okay, and E2 is K times Q, 2Q, because this is minus 2, okay? 2Q over the length of this is root 2 of D. So the square of root 2D is 2D squared. Okay, and we cancel these two out, which means we can see that E1 and E2 they are equal. They're equal. Okay. So because they are equal, and this is 45 degree, this is 45 degree, and if you draw this very carefully, then you can find the summation of E1 and E2 will be pointing in this direction. Okay. All right. Then let's see. This final question. So here E1 is still K times Q over D squared, but our E2 is different. Our E2 is K times 2 square roots of 2Q over root 2D squared, which is 2D squared. And cancel this out, and it's equal to root 2Q over D squared times K, and which this relationship holds. this relationship holds. Okay. So then now we know the direction of E2 and E1 and also the magnitude of E1 and E2. So this is 45 degree because of the direction. 45 degree. Okay. Then the summation of E1 and E2. How do we know this? How do we know this? We have a vector straight down. Straight down. This is E1, okay? E1. And E2 pointing in this direction. In this direction. And has a and it's 45 degree away from the y-axis. Okay. So this is E2. So now let's try to move this vector to here. Okay. And this one, let me draw this in black. This one will be the sum. Will be the sum of these two vectors. So the question is, what's the angle of this one? What's the angle? Okay. So this green vector here has the same length of E1. Okay. We only know that this angle is fixed, 45 degree. But in fact, if we don't know the magnitude of E1 and E2, then we don't know about this angle alpha, because this green vector can be longer. If we enlarge the magnitude of E1, can be longer. Can be this long, can be this long, can be this long, and can be this long. Okay. Okay. But now we figure out that E2 equals to root 2 of E1, which means this number is root 2 of E1. So does that remind you something? If this is root 2 and this is 1 and this is 45 degree, then what will be the angle here and here? It's a fixed triangle, so it has to be 45 degree here, and it's a right angle here. Okay. So now we know that this vector sum C will be pointing to the right. Okay. So here we should choose C, and this we choose B. Okay. So this is all for the assignments on Monday, and again, I apologize for my absence on Monday, and hopefully this videos can help you to some degree. And if you have any questions, feel free to ask me, or we can set up a meeting, or if you want to text me, it's all good. Okay. So see you on Wednesday. Bye.